So this video is meant as a general intuitive introduction to the concepts of transformation and Unit 2. So we're going to be starting to talk about transformations in the coordinate plane, and this is just meant to give you sort of an intuition behind what we're talking about when we're talking about transformations. There are two types of transformations. One type of transformation is called a rigid body or isometry transformation, and the other transformation is a non-rigid body transformation. What I've got here is an XY plane, and I've got a wood chip in the shape of a star, a five-pointed star. And as you can tell, this wood chip is solid, it's hard, and no matter how I move it, no matter how I tilt it around, it maintains its shape and its size. A rigid body transformation is a mapping in the plane. It's called a one-to-one mapping that starts with a pre-image or a figure that's lying in the coordinate plane and then maps it to another figure also lying in the coordinate plane. And in a rigid body transformation, the two figures are congruent to each other. Okay, so if we had a figure that started here, and I'm going to just trace out the border of this star with a pen to indicate a figure that is what we were given to start with. Okay, so that gives us what we're starting with, which is often called a pre-image. Okay, so that's our starting point. And then the mapping, if it's a rigid body transformation, and we're dealing with like this solid object, basically moves it somewhere else on the plane like that, and we have what's called our image. So we have our pre-image, and then we have our image. So let me trace out the image. And I think you could tell, to the best of my drawing ability, that these two figures are congruent, okay, because they're basically made of the same solid wood chip. And we started with a pre-image here, and then we essentially moved it somewhere else in the plane, and we ended up with an image over here. Rigid body motions which are also called isometries, preserve distance, angle measure, betweenness, and collinearity. So let's take these in turn. The following are preserved in a rigid body isometry. Distance. Okay, so if we call, let's say, the points of this star, we number the points here 1, 2, 3, 4, and 5, and we number these points. Let's say this was 1, this was 2, this was 3, this was 4, and this was 5. Then the distance between, let's say, 1 and 5 over here is going to be equal to the distance between 1 and 5 over here. So if we drew a line segment like such, and we drew a line segment like such, those two line segments would be congruent. So distance is preserved, and so are angle measures. Okay, so that if in our pre-image this was the measure, don't know exactly what it is, but let's say that is the measure of angle 1, and then in the image we have a measure of angle 1 up here, those angles will be congruent. So any angle that existed in the pre-image is going to exist unchanged in the image if we have a rigid body transformation or an isometry. Another thing that's preserved is something called betweenness. Okay, which means that any point that's between any two other points would be preserved. So, for example, let's take a look at the line segment between 4 and 2, for example. Okay. Let's say there's a point here that's between point 4 and 2. Let's call it point A. It will turn out that if we draw the line between 4 and 2 in the image, and we find out where it was that point A was mapped to because of the transformation, if point A was between 4 and 2 in the pre-image, it will also be between, it will remain being between 4 and 2 in the image. So betweenness is conserved. And finally, collinearity, as well as, of course, non-collinearity, is preserved. So, for example, in our pre-image, points 1, 2, and 3 are clearly non-collinear. And in our image, points 1, 2, and 3 are clearly non-collinear. In what the line segment 4, 2 that we've drawn, 4A and 2 are collinear. And in the image that is the mapping of the pre-image, 4A and 2 remain collinear. So the whole concept of a rigid body motion is that the two images are congruent with each other. Well, what kinds of rigid body motion or isometries do we have? Let's go back to the example of our wooden chip. Okay, so we've got here, let's say this is a pre-image of our wooden chip. And let's say that this is the image of our wooden chip. So we've started with this, and we've ended up with this. This is an example of one of the types of isometries. It's called a translation. A translation is a movement that does not involve a rotation or a reflection. So, in many ways, it's a very plain movement. It's basically a sliding of the original object in a certain direction without rotating it. We don't have any rotation involved. And we don't flip it over, which is what a reflection is. So we're going to talk about those two movements in a moment. But if we don't rotate it, and we don't flip it, but we simply just move it somewhere else in the same configuration, we've performed a translation. Okay. The second type of rigid body movement we've now referred to is a rotation. So let's talk a little bit about rotations. A rotation is a circular movement around a center point. So let's talk about an image like this wooden chip. And let's say we have a center point here, which is our origin. And let's say, just like the way we move our compass, we actually take this chip and we rotate it around the origin like that. Okay, what we have just done is a rotation around the origin. It It is a rigid body motion. It's too bad my finger's blocking part of it, but I think you get the idea that basically the entire object is being rotated. We can rotate it at any given angle that we choose and around any point that we choose to rotate it. In this case, we're rotating it around the origin, but we could pick any point on the plane and rotate it. Okay, so that's a rotation. And finally, we've got something called a reflection. Let's get another clean set of axes. In fact, we don't even need an axis. All we need is a point, is a line, rather. So let's talk about reflection. And when you think about reflection, you're probably thinking about something like a mirror. A mirror reflects light. And a reflection, which is an isometry, reflects an object. So let's say that we start with our object here, and this is our mirror line, or our reflection line, be called lots of different names. The way we reflect an object is to essentially flip it over the line like that. We have just reflected this star-shaped object over our mirror line or our reflection line. Let's actually take a look at what a pre-image would look like and what the image would look like. So I've kind of lined these two stars up in such a way that they are pretty close to being a reflection. It's as if they're looking at each other through a mirror. If one of them moves up, the other one is going to move up too. If one of them turns in such a direction so that this point is pointing towards the mirror, the other one will adjust so that it is like a reflection in a mirror, and this point will also be pointing towards the mirror. So what you've got in a reflection is you've got, let me just adjust it a bit, you've got a pre-image and an image that look as if they're mirror images of each other. That's exactly what's going on. So this is just meant as a general idea to introduce you to the concepts of translation, rotation, and reflection. And we're going to be talking an awful lot more about this in the next few videos.